are live for October 28th, 2021. Thank you for joining us. Let me turn off my sound on this other computer here, and we are ready to rock and roll here. Thank you, everybody, for stopping by. We are some discussion today. No guest today, but a little bit of discussion today on let me get going here. Get my setup up and operational. So we got a couple things we're going to talk about today, and I think there's going to be some interesting information for you. But first, I wanted to dive in a little bit and talk about the National Groundwater Association coming up. This is in December, so they've actually split the summit and Groundwater Week into two separate events. So the Groundwater Summit itself which is really for the professionals, is going to be December 7th and 8th online. So it's going to be online only. So that's going to be all the talks and everything are going to be online. It's always a good event, so you can sign up for that. And that's coming up December 7th through 8th. So there's still time to register. I think the early bird may be over with, but certainly there's some interesting talks coming up. If you look through here on the National Groundwater Association page, some interesting program coming up. So the following week here in Nashville, they are going to have the actual Groundwater Week, which is going to be the live event. So that's going to be December 14th, 15th, and 16th. The exhibit hall is going to be the 15th and 16th. So I would say if you're going to be in Nashville for this, please feel free to look me up. Contact me. I'd love to meet you, and we can chat. I'd love to hear what's going on, meet in person. I am planning on being there for the full event, dedicating those 3 days. Now, there is going to be some classes here too. They're probably going to be more geared towards the some for the professionals, but it's going to be mainly more towards drillers and the vendor type classes. So it's going to be a little different character than the Groundwater Summit the preceding week. But that's what's coming up. If you're not already registered, you can do that at the National Groundwater Association site. And once again, if you're going to be in Nashville, look me up. I will have my contact information later in the show, and you can certainly connect with me, and we can chat, and I can show you the high points of Nashville too. Stuff to enjoy while you're here. Okay, moving on. What we want to talk about today is what small water systems should be doing now, and we're really moving into the so-called slow part of the season, and over the winter and stuff, things slow down a little bit. I know for all you guys that operate water systems, it never really truly slows down, but you get a little bit of a reprieve, so maybe a little time to catch up and reflect on things. So I just wanted to, from our perspective, we work mainly with small water systems, and so people there wear many hats and don't always have the budget to do what they wanted to do and things like that. But just based on our conversations with folks at small water systems and some of the problems we see on a recurring basis, here's some of the things that we wanted to talk about today that people can do at the small water systems to really maintain their system in tip-top shape. So what we want to talk about today is 5 high-value tools, and I consider these high-value tools, and that really means you're getting the biggest bang for your buck with the money you spend on these things. They're not hugely expensive, but it's as on an ongoing basis, they pay huge dividends. So these are relatively high-value tools that small water utilities should be using. So number one is asset management. And asset management really isn't something that's just for the big guys. It can be employed by small water districts as well. We work with a lot of small water districts, and you can come up with a asset management program that is not terribly onerous. It may not be as incredibly sophisticated with with lots of computer models and expensive software that maybe some of the bigger systems use, but it can really help you planning wise. And let's just look at some of the points here. Is it can really help you planning wise to maintain your budget. So if you know what's going to probably break when you need to replace things, you're miles ahead on your budget and able to plan for those things. And it's going to be better when you can plan to replace something as opposed to replacing it on an emergency basis. That's always more expensive. So really what you need to do is you need to make sure you have an up-to-date asset inventory, and this can be accumulated over time as you go out and do repairs, you do replacements. You should really just, even have like a spreadsheet where you're keeping track of these things, where they're located. Just even a simple handheld GPS can dial you in on where these valves are at, these hydrants, and whatever component you have in your distribution system. That should all go into a database of some sort, even if it's as simple as a spreadsheet. So you want to understand what that asset condition is. What is the condition? How likely is it to fail? So you want to basically assign it some kind of category, and a lot of people will use like a numeric method to really categories at 1 to 5 is how good a condition it's in. Maybe 1 is brand new, 5 is imminent failure, and then in between, it just helps you plan. And then that leads to the next point here is, now you're starting to look at what is the predicted life of this asset? How much life does it have left? And the actual condition of that asset when it was installed will really help you determine what the predicted life is. I mean, obviously, most things are going to, if you look at some of the US EPA tables, they got a lot of asset life tables in there for different components of your system. You can use that as a general guideline, but whoever your manufacturer or vendor is can also give you an expected lifetime on these things. So you have to look at when it was installed, what the condition is, and where you are at in the predicted life of that asset. And now if we know if this particular valve has a 10-year life remaining, you can start working on a capital improvement program that allows you to replace that asset when you're starting to get close, when it's starting to get to end of life. So, and obviously, in the world we live in today, replacement costs are the original cost of that asset. It's going to cost more to replace, so you need to budget for that as well. Everything is going up right now, and it's and if you look at the supply chain problems we have right now, long-range planning on these things is more important than ever because we're seeing a lot of people having difficulty getting parts and supplies and being able to replace things. So you have to have a little bit longer term planning horizon than you used to. So how long that will last, hopefully we will get these things resolved, but at least in the short term, it's we definitely are seeing the pinch out there, and people are having trouble getting the supplies they need to do the repairs and replace the assets they need to. So in that situation, a much longer term outlook is really what you want to get into is to plan those things out. And then obviously for small water districts, especially where money's always short, you need to budget accordingly. And if some things are coming up that are major expenses, major capital expenses, now you can start looking at, do I need to apply for an SRF grant or loan to replace these things? Because really, if you're getting into any government-related funding, SRF and other programs, USDA, US EPA funding, these things really take a lot of time. You're looking at a year and a half out, 2 years. So it's really important to have that planning horizon so that you can have the money available when you need to replace these assets, because the last thing you want is to have emergency rate increases to pay for some things that you possibly could have been adequately handled through proper planning. So that's asset management. There's a lot more to that. We teach some classes on that and help people through that process. But really, it can be asset management can be as sophisticated as you want it to be. It's you can really create some pretty heavy duty models, and for large systems that have a lot of components, they tend to have fairly sophisticated asset management models. Smaller systems probably don't need quite that level of management or software. There's a lot of simple things you can do that don't cost you a lot of money. It's a matter of usually it's more taking the time to do it than it is the money. But the time is well invested. Like I said, these are all things we're talking about today that are high value types of things you can do, and really properly managing the assets of your system is really a high value thing, because there's a lot of benefits to that, and in the long run, saving money is good. So let's move on here. Oops, well, let me fix this here. Sorry about that. This should really read. Kind of doing this on the fly. Sorry, I didn't have that edited quite right. But the next thing we really want to look at is the well health check, and a lot of this stuff we're really talking about falls into the asset management category. But well health check is really asset management for your water wells, and it's really something that a lot of people don't do. We see out there the run to failure model, or run it till it breaks, or whatever is the most common management technique for wells. But it really doesn't have to be, because a well is a pretty expensive asset. You're talking, these things can, for a small water system, you can be upwards from $200,000 to larger municipal wells. $1.5 million or $2 million is not that uncommon. So it's really an important asset. And what we want to do is we want to go in there and we want to regularly monitor the health of these things. So the way we look at that is there's a number of components we do to the well health check, and when you first do it, some of these things you're going to do and look at, and then it becomes more a matter of updating this over time. So subsequent, we recommend you do the well health check on an annual basis and track these things in a spreadsheet, graph them out, and keep records. The data you develop, it's really important. What a lot of people do is they look at it, they make sure that everything's fine, and then they throw it in the file and they never use it again. Well, you spend a lot of money to develop that data. You really want to use that. And the well health check is additional data you're going to develop, but you're going to combine that with other things and allow you to track the health of your well. And what that's really, the ultimate point of this is to get down to what is the optimal time to rehab our well. You don't want to, it's like the Goldilocks principle. You don't want to do it too soon. You don't want to do it too late. You want to make it just right and hit it at the right time, so that you're spending your money wisely. Well rehab can be generally a fairly expensive proposition in most cases. So it's something you want to you want to do it right, and B, you want to do it at the right timing to maintain the health of the well. And a properly maintained well obviously is going to last you the longest and give you the lowest cost over the lifespan of that well. So the well health check is an important component of this. We teach a whole class on this actually on a monthly basis. So if you don't see me on LinkedIn or whatever, when those classes are coming up, let me know and we'll get you signed up. We go through the whole process. But in a nutshell, what we're doing is we're looking at physical parameters like your energy use, standing in the well, your specific capacity. Those are all physical type parameters, well efficiency. And so we track those over time because, for instance, when we look at energy usage, we'll look at something like gallons per kilowatt hour, and that's telling you that's a way to get to the efficiency of the well through power consumption. A well that's plugged up and the water isn't flowing as freely into the well is going to use more power. So the gallons produced per kilowatt hour expended is going to go down over time. You can actually track that and graph that. So that'll tell you if you got some plugging going on. Specific capacity is another thing. Specific capacity is really gallons per foot of drawdown in the well. Those numbers will decline as the well plugs up too, so you can track that also. And these are some things that are really easy to do and cheap to do to track the health of your well. The next thing that's part of the well health check is chemical parameters. And we really look at a variety of, you have your water quality analyses you need to do to monitor the water quality in your well. For instance, total coliform and bacterial contamination, other types of constituents. You need to monitor those on a regular basis. We're talking about a few different parameters. For instance, you're probably monitoring total iron in the well. We tend to break these things out into iron 2 and iron 3, so we tend to speciate the iron because different iron species can tell you different things. Iron 2, for instance, increases in iron 2 can tell you if you have ongoing corrosion in your well. So that's something to track. So there's a variety of parameters we look at that'll tell you, how likely you are to have mineral incrustations, what type they are, so there's a list there. We go over the full list in our class, but just understand here today, quick intro is we're looking at a variety of chemical parameters that are not so much looking at the water quality, although they're eventually going to be tied to that, but we're really looking at parameters that monitor the performance of the well rather than actual water quality, which is important. So plugging in the well, what type of plugging it is, with the ultimate goal of really coming up with the most effective well rehabilitation possible. So we're going to take all these things and we're really going to come up with a well rehabilitation plan that's going to be the most cost effective for that well. What you don't want when it comes to well rehabilitation is a one size fits all approach, because those are seldom the most effective. Sometimes they work, sometimes they don't. You really want to dial things into your specific well, and that's what the well health check parameters are really looking at. Next on the list is microbiology. It's something, probably 80% of well plugging cases are going to have some component of biofouling to them. So you're going to want to know what kind of bacteria are you dealing with, where's the bacteria at, and how do you deal with that. So that's going to be part of your well rehab formula. And so we use water systems engineering for both our chemical and microbiology analyses, and they give pretty spot on results there. So we know exactly what type of bacteria we're dealing with the well, and what types of problems they can potentially cause. The other thing we want to look at is the well logs. A lot of times when we have problems with wells, we can relate that back to well construction or well development in a lot of cases. So we want to go back and we look at the well logs, and a lot of times we can pinpoint problems, for instance, nitrate issues in a well. A lot of times are related to well seals. So a lot of times we can look at the geology that was logged in the well log, and we can look at where the well seal is and see if that's going to be an issue that can create nitrate problems in the well. So, and a lot of times, I'd say 90% of the time, nitrates are a well seal issue. Your mileage may vary on that, but my experience has been it's almost invariably going to be an issue with the well seal. We can get at that by looking at the well logs. We're also going to want to know the maintenance history on that well. How long, when was the last time it was rehabbed? What did you do in terms of rehab? And so we can kind of that gives us an idea of how bad things may be and really what we need to do there. We want to look at any well videos you might have. And if we don't have one, you probably want to do that. We'll address that here in just a few minutes. But we like to look at well videos because it really gives us a handle on what's going on down the well. We can judge the degree of plugging. We can get a look-see and usually tell from the well video basically what kind of mineral incrustations you have and what level of biofouling you have. And so well videos are really an important component, relatively inexpensive to do. Most people tend to do them on a semi-regular basis, so you can actually compare one well video to another and see how quickly your wells are plugging up. That's valuable data. You're collecting water quality data already, so we kind of plug that in there too. Are we getting any changes that can indicate plugging going on in the well? Sometimes when wells plug up, you will now start to draw water preferentially from certain aquifer zones, and some of those may have water quality issues. So you may see different water quality issues developing as your wells plug up. So that can be symptomatic there. So we're going to want to review that and any other relevant data, any repairs that were done, anything like that is all going to be part of that. Now, the first three on this list are things you're going to want to do every year as part of the well health check process. These other ones, you're obviously going to want to review any new well videos and update the well maintenance and just basically kind of keep a database and look at this information. But some of this stuff is going to be things that you're obviously not going to have to go back and look at the well logs every time. So, excuse me, my earpieces are falling out here. So, it's what you get on live. You get the real thing. Okay, GIS updates, and once again, this is kind of an asset management thing. So if you don't have yourself set up your water system into a GIS system, it's kind of like, why not? This stuff has actually gotten pretty affordable. It's really reasonably priced. Once you get it set up, then adding to it is really easy. So it makes it easy, and I'll tell you what, it makes your life so easy when you have everything in a GIS system. You know where all the valves are. You can tie that back into your asset management, so you can basically take your GIS system and look and see all valves that are over 20 years old, for instance, and just start looking at things. If you have particular problems in a particular area all the time, you can dial that in with the GIS. But just keeping track of things, where are you getting that leak? You can start to isolate areas in your distribution system, different zones in your distribution system that you can dial in on and track down leaks. So a lot of uses for doing the GIS. It's what I call a high value to cost ratio. And once you get this set up, you'll be using it every day. It's an awesome tool. There's a lot of third-party services out there that make it really easy. We recommend and work with Diamond Maps. That's diamondmaps.com. And basically, they'll set you up, and the cost is $20 per month per user. So if you have one user, it's basically $20 a month, which is, going to be, probably less than the cost of paper supplies for your printer in your office. So if you have multiple users, then you multiply it by that. But this stuff, you can go online, you can check it, while you're at home. You don't need to be in the office. It's really slick. So I would recommend, if you haven't done this, to talk to Ben at Diamond Maps. We're going to get him on here. He's been out and about, so we're going to get him on here and do a whole show with him at some point. But he's a great guy and can help you out. There are other tools out there as well. I'm not going to go through them all here, but there are other tools as well. The Diamond Maps is just one we're familiar with and have worked with, and I know how easy they are to use. So a GIS tool, great time when things are a little slower is to start getting all your system data together and get it into a GIS system, and you know, you'll be happy you did once you have that set up. Okay, now during the downtime, pump maintenance and what the heck when you have the pump out to do maintenance on it. Let's do a video at the same time, and that's important. Pumps, we obviously want to maintain those. Obviously, just like wells, pump performance is going to degrade over time, and for some of the same reasons. You can get mineral incrustations and biofouling in your pumps just as easily as you can in your well. But if you have, for instance, sanding going on in your well, the impellers on your pump can wear down. Pump bowls can be impacted. So you're gonna, and just the motors will need to be overhauled every now and then. It's, in the grand scheme of things, it's relatively low cost maintenance. The biggest cost usually is, it usually costs more to pull the pump and put it back in than it does to actually overhaul it. But once again, it's a high value and high benefit for you is to have your pump operating at peak efficiency. It's going to really save you on electrical costs in the long run, and so that's important. There are people out there that can actually do the pump check. John Lee with Pump Check is an outfit in California that can do that. He does great work. John's another guy we're going to try to get on here at some point to talk about the process. They go through a whole series of tests and tell you what the efficiency is and what improvements you can make. If you're in the area of Southern California, Edison, I believe they're still doing these pump checks for free. So that's another option as well to get a hold of them. I know there's a little bit of a waiting time, but it's certainly something you can look at. And you can there are calculations, and you can look this up online how to do it. We include some of this in some of our classes as well, but wire to water efficiency is a relatively simple way to look at your pump and motor efficiencies, and that's important because if you're really looking at declining performance in your well, then you really want to know, is it the pump and the motor, or is it the well itself? And sometimes there's components of both, but one time it may be more heavily weighted in favor of one or the other. So if it's the pump, then it's a matter of pulling the pump and doing the overhaul or doing the repairs you need to on the pump, and maybe putting off the well rehab. If it's the well itself, then we got to look at doing some rehab. So this really is a situation where you can really dial some of these things in and determine what the cause of decline of production is, and like I say, it's a high value to you compared to the cost to get this done. So pumps aren't going to need to be maintained every year for the most part, but it's really going to depend on the characteristics of the groundwater in your well. Some groundwater is a little more conducive to forming mineral incrustations. We've seen wells that have been rehabbed 5 years ago that basically you run a video down there and the turbine pump looks like a big stalactite. It's got so much in the way of mineral incrustations on it. So, and some you run it for 10 years and the pump bowls are pretty clean, but you get any sanding coming into your well, that's going to erode away at the impellers and the pump bowls. So those need to be checked also. So a lot of things there, a lot of benefit. So, and when you have the pump out, that's the time to run a well video. There are video cameras you can do out there that you can sometimes thread them past the pump, especially if you do a lift and shift, move the pump over so you can get some clearance. It doesn't always make it. So that's kind of hit or miss. We generally recommend using a full-size camera and running the video when the pump is out, and it's well videos in the grand scheme of things are relatively inexpensive and allows you to track what's going on in your well. There's no substitute for actually seeing what's going on down there. And I can tell you that from the standpoint of a guy that looks at a lot of well videos. Um, you know, spending instead of watching movies at night, I'm watching well videos. So, so that's my life. Anyway, but a well video is a great tool. So if you got the pump out, run a well video. It's really important. And then what you're going to want to do then is compare the videos over time, and you can see the progression of plugging happening, whether it's biofouling, whether it's mineral incrustation development. You can see that happening over time, and then you can get a gauge. Actually, it's kind of a more qualitative than quantitative type gauge, but you can get an idea of how quickly your well plugs up, and that kind of guides you into planning and budgeting for when you need to do the well rehab. So well video is a great valuable tool, and I recommend everybody do those on a fairly regular basis. May not need to be done annually, but certainly every other year. And when you pull the pump to do any pump work or to clean it up, then run a video. That's my advice there. All right. Next up is exercising backup wells. A lot of water systems, most water systems will have some sort of backup wells, and a lot of times those don't get the attention they really need to. And the reason for a backup well is to have it there when you need it and be able to pump water if you need it. And if it's not in shape where you can just turn it on and flush it a little bit and start going, then you really need to look at a program to monitor that backup well and exercise it on a regular basis so that it's good to go when you need to. Is the pump operational? You're going to want to check that, run it long enough so you can do some pump efficiencies, the wire to water, and do those calculations and make sure the pump is still okay, and then do some testing. So what we want to do there is understand that stagnant water, especially in backup wells, is a breeding ground for coliform bacteria and other type of bacteria. Stagnant water, we see it's a real common problem in backup wells that they have total coliform issues. So it's something that when you first start these things up, you're going to see total coliform hits coming out, and that's the reason is total coliform tends to proliferate and grow in stagnant water. So the same reason we see wells that are heavily plugged with biofouling, you develop stagnant zones. You also tend to get total coliform in those types of wells. So it's the same situation here. So that's one of the big issues, but it's a common problem with backup wells. You got some other problems. You can still get bacteria growth, not quite as fast because the water probably is not quite as oxygenated, but you will get bacteria growth. You can get some mineral incrustations developing, probably not as quickly because the water isn't flowing into the well, but the coliform issues and just corrosion issues is another thing to look at as well. And the pump issues are really things you got to pay attention to. So you want to do a condition assessment on these things just to make sure that they are ready to go if you need them. And you never know when you're going to need your backup well, so it needs to be ready to go. The worst thing in the world that can happen is you have a backup well that you're counting to be there, and it hasn't been well maintained. Now you need it for some reason. The pump goes down in your main well, and you need your backup well, and your backup well is not ready to go. So you really need to treat them as an asset is really what it comes down to, and they're an asset just like everything else. So the common theme here has really been is that a lot of these things are we're dealing with assets, and for the most part, this is all part of the overarching asset management program you should really do. So it's not that complicated. It doesn't have to be that complicated, but it's things that take a little bit of time. You got to set some time aside to do these things. Some of these things are going to cost you a little bit of money, but you can budget for those things. But for the most part, the things we presented here are things you can invest your money in, and it's money well spent. Okay, so let's recap real quick. So these are the 5 high-value things I think small water systems should really be looking at as we move into the so-called slow season here is asset management, really understanding what your assets are, how much life they have left, when you're going to need to replace them, and developing a budget around that replacement schedule. The well health check really gets at, taking a snapshot of the health of the well and understanding what's going on in your well, and getting back to when am I going to need to rehab this well and how much am I going to have to budget for that. And it also helps you develop a very specific well rehab approach instead of just a one size fits all or guessing. You're spending money on that well rehab. It's going to be reasonably expensive. You want to do it right. And the well health check really gets at that. So you can basically, the end point of that well health check should really be a recipe you can hand to your well rehab contractor and have them bid on it. And you know that it's going to be done right. It's going to be address the specific problems in that well. The GIS system and updating that on a regular basis, really important. A lot of bang for the buck there. And we highly recommend that any size system. It's so cheap these days to do those things. There's just no excuse not to do it. And these guys will walk you through it and get you set up. So they're very helpful. Pump maintenance and doing a video at the same time you do your pump maintenance. That's just something you want to do. An efficient pumping system is really going to save you a lot of money in the long run in energy costs and just headache right there. You want to make sure that doesn't go down at critical times. And then exercising backup wells. Like I said, stagnation in backup wells creates problems, and you want to make sure those things are really ready to go when you're ready for them or when you need them, because you never know when that's going to be. All right. I have a few news stories I wanted to go over real quick here. And let's just look at some of these things here. Some of these are just some news stories that caught my eye this week that I think are relevant, and so I just wanted to run some of these things through real quick. We're certainly seeing some lack of snow, especially out west, and it's really making a shift when it comes to groundwater resources and management of those groundwater resources, because the snowpack, especially when you get in places like California on the West Coast, the snowpack is really important to recharging the aquifers, and really it's we're going through a period here where the climate is we're doing some extended drought periods or at least lower precipitation periods, maybe going back to what might be called a geologic norm for the area. If you look at things in terms of geologic history, but whatever, however you attribute it, we're certainly seeing lower snowpacks than we've seen in the past, or at least periods of time of low snowpack, and then we may get a normal one, and that affects groundwater recharge and ultimately affects the availability of groundwater as well as surface water. The runoff from in the spring fills the reservoirs and dictates surface water deliveries as well. So the snowpacks out west are incredibly critical environments that we need to monitor. And if we're not getting as much snow there, we need to just come to the realization and understand how our water management has to change to deal with that. So this is really an article talking about that. There's some work being done at Lawrence Berkeley National Lab, or Berkeley Lab for short, and talking about they do a review paper here, low to no snow future and its impact on water resources in the western United States. So they're really looking at 5 specific areas here: the Sierra Nevada, the Cascades, what they term western U.S., the Rockies, and in Utah, the Wasatch Uinta front there, and looking at projected snow loss and how can we manage things a little bit better. So definitely a good article. I would suggest checking this one out. it's if we can shift our thinking, and I talked last week a little bit about our short-term thinking on water resources. We need to shift our thinking to longer-term planning, and that's really what this paper comes down to is long-range planning, and we just don't do enough long-range planning on these things. A lot of these things are driven by available funding, which is being driven by the political environment, and politicians are basically concerned with getting reelected. So we don't give much thought process beyond the next election cycle on these things. That really has to change when it comes to water management. It has to be a long-term outlook, and that's really what this article is getting at here. So we talked. This is an interesting one, and this should come as no news for the geologists in the crowd, but this is actually a study that was done in Australia where they say, well, instead of just going out and drilling a lot, how about if we use satellite photography and geology, and when we're looking at fractured rock systems especially, that we dial in on things using our fracture trace. So they're really combining satellite imagery and geospatial techniques with pre-existing information on drainage, rock types, fractures, topography, and rainfall. So kind of bringing all these things together into a GIS system. And for those of us that do water well locating in fractured rocks, you understand the whole fracture trace and liniment analysis here that we can do from aerial photography, satellite photography, and bringing in some of these other things to help us find the best location to drill test borings. I mean, obviously you're still going to need to drill, but the old school of just going out and drilling a bunch of test wells without doing some office study, and actually the office study really these days, when I do it anyway, is the most important component of things right now. Is we want to look at and look at our fracture traces. We want to look at the geology, and then we're going to go out and do our field work and locate our test well locations based on that. So this is an interesting article in Water World. For those of us who locate water wells, it's really nothing new, but it may be good information to pass along for somebody that doesn't understand what we do when we're looking for water wells, or if you don't understand how the process works. This is a good article here. This article here, PFAS, of course, is all the big news out there, and the Army Corps of Engineers has apparently come up with a patented technique now for removing PFAS. It looks like it's got a lot of promise here. I mean, they're doing 1,200 gallons per hour in these remediation systems, so you could probably even scale these things up, and they're seeing some good results here. So this is patented, or it's been submitted for patent, I guess, by the Army Corps of Engineers. I assume it will be available for licensing, but it's something that they've been working on for treating PFAS. There are another number of treatment techniques out there that people employ with varying degrees of success. And this one apparently looks like it's got some potential here. They in some testing at DoD facilities, they removed PFAS from 80,000 gallons of water to a level of 70 parts per trillion or less. So some good progress there. They ran it for almost 70 hours to treat that. And so it seems like it works pretty well. So they're going to do the technology transfer process and license it to private companies. So if you're in the remediation business, this stuff is available for licensing it at some point through the U.S. government technology transfer. So good news on the PFAS front, because that's basically, when it comes to groundwater contamination, that dominates the conversation these days. That's for sure. So Here's something else we talked about last week. It's the Open ET program for looking at managing water in basins by using satellite photography to break out crop types and that type of thing, and really dialing in on water usage based on crop types and agricultural areas, and better management of water in the basin. So here's just some more information. This is actually on the Environmental Defense Fund site. You can look up this article and some interesting information there. We're increasingly seeing use of the satellite technologies to satellite photography and aerial photography, and combining with the different GIS techniques and filtering to really come up with some good management of water. And this is really what we need for our long range planning that we talked about. So that's data is important to long range planning. You can't do long range planning without data. And the simple fact of the matter is we don't have enough data in a lot of these groundwater basins to really understand what's going on. We can make some guesses, but the more data we have, the better our management techniques are, and we can get into that long-term management mode. So we're happy to see this this technology coming out there, and there a lot of people are using different techniques like this, but this is definitely a technology that you want to keep your eyes on, and especially for those doing basin plans and groundwater sustainability plans. This is data that you really need. And lastly, here we go. This one just a little caught my eye, and a little humor to wrap things up with is beavers wreaking havoc on New York town's water supply. So Mechanicville, New York, has a little problem with beavers. They use a surface water supply, and as fast as they can take the beaver dams out, the beavers are building new dams. So it's basically whack-a-mole when it comes to the beavers here, and so you never know out there what's going to happen. So a little humor there is dealing with beavers when you have a water system that deals with surface water from small drainages. And it's amazing how quick a beaver can actually build a dam on a small stream in just a couple days. They just go to town, and it's amazing to watch how quickly they can build those things. So okay, that's kind of it. Look at what small water systems can do today. Look at the National Groundwater Association coming up, and some interesting news out there in the water world. So we thank you for joining us. Let me just show you real quick here. We do have a YouTube channel that you can look at these. We live stream into that. You can watch that. And so we live stream there, and the recordings are there as available on the YouTube channel. The Groundwater Guy is the easiest way to look for it. Otherwise, you insert a long cryptic URL. So just look up the Groundwater Guy channel, and you can see the replay of this show and past shows. We do have a Groundwater Talk Live Facebook group. If Facebook is your thing, we really don't get much traffic there, but I have it there for the sake of completeness. So I do stream into that as well. The recordings are there if you want to watch them there. If you want to be a guest on Groundwater Talk Live, and we're always looking for good guests that have information that's relevant to the water resources industry, we do have a booking page. You can get on there and schedule. We run every Thursday, 9 a.m. Pacific time, 11 a.m. Central time, and so you're free to come on Thursday, schedule it up, and we'd be happy to have you, whether you want to do a presentation or do an interview style format. That's really what we got going on, and we got some interesting reviews on there already, and you're more than happy to peruse those and watch those and comment on them if you will. So you can get a hold of me on LinkedIn. This is my LinkedIn profile. You can leave me a message there, contact me there. If you're going to be in Nashville for the National Groundwater Association, drop me a line here on LinkedIn. I think my email is on there as well. So be sure to contact me there. And lastly, if you're watching this on replay, please feel free to post comments below. The more comments you post, the better distribution and the more look-sees we get out there. So that's helpful to us, even if it's popping in and saying hi. But I'm interested in your honest comments, and I always respond to your comments on these videos. So feel free to leave a comment, and we encourage that. And that's it for today. Thank you very much. We look forward to seeing you next Thursday, 9 a.m. Pacific, 11 a.m. Central on Groundwater Talk Live. We're signing off. I'm Tom Ballard, the Groundwater.